next, I have some popular GCP design choices. So like I said, this is a comprehensive platform that we have. There are a number of different options and design choices, but I will stick to the popular one. Okay, so the first one is with the shared VPC. So this is a concept in GCP where as an IT admin or as a network and security owner, you can create a host project and then you can create the subnets and the firewall rules that you can check out or extend to your developers. So those developers will be sitting in the service project and they will get this subnet from you as a network admin. Now, important thing to remember that a lot of people are confused that this is going to solve their transit networking for them. That's not true. This is not a networking concept. This is mainly an admin concept where the central IT or central admin can create those subnets or network and can hand off to the developer so that they can deploy their applications and they don't have to worry about all the routing. You will take care of it, right? And also, this is not equivalent to the peering, native peering, okay? So don't confuse there. So we understand this concept. You can see in my slide here, I have created some subnets, which I'm sharing with the service VPC. And this is how the architecture looks like. So now we have this hub and spoke architecture deployed with Aviatrix components. You can see this host project is there. And then I have extended or shared the subnet to a service project. So now this workload or this app is connected to this hub and spoke architecture and with the understanding of the shared network. So this makes life a lot easier for our GCP customers who are going to shared VPC. Obviously, if you don't have a shared VPC, you can still achieve the transit routing and all the functionalities without shared VPC. But if you have a need for this type of architecture, yes, definitely we support that. And you can see the deployment details here on this URL. The next is about serverless compute. So in AWS, they call it Lambda. In GCP, they call it cloud functions. So what happens that when you're writing these cloud functions, the cloud functions are just sitting there locally on your serverless compute, right? So what we can do, we can bring this cloud function and make it part of your transit architecture. So here in this example, you can see I have this cloud function, my code written here, which I can connect using a VPC connector to my spoke VPC here. And then this spoke VPC is connected to my hub or my transit gateway. Now your cloud function is not sitting in isolation, it's part of this architecture. And once it becomes part of this architecture, you get all the benefits of it, right? For example, inserting a service or a firewall or a checkpoint or Palo Alto or FQDN into the mix, right? So we actually enhance the cloud functionalities in the cloud. And not only that, if you are extending to other cloud, could be Azure, could be AWS, this is now extended to those clouds as well. So you can now see that your cloud function is talking to in GCP and also in the other clouds. So we are making it a lot better with the architecture that we have. Okay, a lot of customers I talk to, they really like the GKE, they really like the Kubernetes, and that's the workload that they have. So we have validated design, we have validated deployment where customers are using our solution to make sure that when they are deploying these clusters, the GKE clusters, they are part of their network. Because when you create this GKE cluster, they are basically local here in this VPC, but what about if they need to talk to some other clusters in another VPC? So that's how you can connect them and provide this connectivity across GKE clusters. Now, if I take this idea and extend it a little further, now I see another use case adding to this GKE architecture. Now, what about if these clusters or the applications that you have deployed, they need to talk to the external entities? It could be an API gateway, could be some other SaaS service, or could be connectivity to GitHub to download the new code or to some patching service. Now you need to provide the security for the traffic that is leaving from GKE and going towards internet. The one option is to create the security groups and block the traffic or allow the traffic, but that is not scalable because oftentimes these services in the background, they keep changing their IP addresses. And you don't want to be in the business of creating those rules yourself without any policy. So that's why it's very important that you understand or utilize the Egress FQDN functionality so that you can talk to these providers or these services in a secure fashion. Okay, so what about extending this to the on-prem? So again, very easy and simple with the architecture. You have this transit VPC here, right? And then now you can use Google Interconnect or simple IPsec IPsec tunnel over public internet to connect to the on-prem. In the on-prem side, this could be any flavor of data center. It could be any software-defined or non-software defined data center that you have where you have created these clusters. Now they become part of your overall network with the security, with the encryption, with all the advanced traffic engineering, all the advanced netting capabilities that you need for this architecture. Okay. Okay, let's talk about the Aviatrix Transit for Google Anthos. So Istio is a commonly deployed service mesh project, which is supported by Google. And the service mesh itself provides application level discovery, segmentation, registry, and discovery options. But the thing that you need to remember that traffic stays within a Kubernetes cluster, right? Which is typically your VPC or VNet. And the CNI plugin that you have, it will take care of that. But the reality is that you're not deploying your applications in silos, in one VPC or one VNet. Your applications are typically extended across multiple clusters. It could be in different cloud. So who's going to provide the advanced networking and security service control for those type of workload? So this is exactly where Aviatrix platform comes in. So now this Istio or service mesh can solve the layer 7 issues, but for all the networking and security connectivity and the segmentation and the encryption, you can leverage Aviatrix hub and spoke transit-based architecture with all the other features that I explained, right? So with this architecture, the Aviatrix platform enables Google Anthos to build secure and robust connectivity between GKE cluster wherever they reside. It could be in just in GCP or could be extended to on-prem, or if you have deployed it in AWS, for example, or Azure. So that's the challenge that we are solving. And with that, you can see in this example, I have some blue VPCs in the prod security domain. Then I have some green in the dev security domain. Now I can create a policy through Terraform or through API or through the controller UI, which will just block the traffic between prod and dev in just one single click. So that's how powerful it is. If you want to know more about this use case, you can go take a look at this community link where we have discussed this in more details.